Okay.
So good afternoon, guys. How are you? I'm Semanish. So today we are going to see about modular programming with Python scripts and Jupyter. So if you have any question, you can stop me and ask. So these are the outlines. So we first start by defining what a modular programming is, and then we see why the modular programming is important, why it matters, and then we see how we create a Python modules. Then we also see the creating package, and we also see importing packages. Then we'll see some tips that are important in the process of writing a modular code. Then we see the Jupyter notebook, what it means and why it's useful, and then maybe if it has a limitation, what's the limitation of using Jupyter notebook, and we'll see some demonstration, code demonstration. Am I audible, Carol?
Yes. Yes, you are.
Oh, okay. So what's a modular programming? A modular programming is a software design technique that emphasizes breaking programs into independent, reusable components. So we call them modules. So modules are like the components in your software, or you can look them as a room for your software. So they can be built using functions and classes. I think you may know what function and class mean in Python. Uh, and the second is it enhances code readability and maintainability. So when you say that readability, because modular programming helps to be the code readable, because when you write each module should have a clear purpose. And so when you have a module with a clear purpose, so which means you avoid long or tagged scripts. So that means that every module has a meaningful unit with clear purposes. So anyone can easily read and understand. And we mean by maintainability, which means, so if something happens, I mean, if something breaks or if some error happens, you can exactly go to that place and you can fix the problem. For example, if you want to update one part of your program, then you can without breaking the entire program, you can just go and update that specific program you have. So which helps us to avoid confusions and bugs. So in general, so we mean that a code is readable, so which means it's easier to understand. And the code is maintainable, which means it's easier to fix and improve. And the third one is, so when you have a modular program, so it helps you to reduce duplication. So for example, when you write your code in one notebook, in either in Jupyter notebook or any other notebooks, so you may have to copy and paste the program that you have in order to perform some tasks. So when in the process of copying and pastes, for example, if you update somewhere, then you may forget to update the second one. So which gives you some problems. So but when you have a modular program, it reduces duplication and improve scalability. So a modular program, so we say it's scalable means, so you can add new features to as a new module. So you can add any module, I mean any new module as you want. And you can also rewrite the existing module. without disturbing the general program. So this is what we mean the scalability mean. So why it matters? I mean, what is the benefit of having a modular program? So, for example, I mean, let's look. This one represents a complex program that you have. Then, when you have a modular program, means you have to break it down to separate pieces. So it may be this one, or any other pieces. So which means that it encourages. So when you have in the last one here, you will have a clean and organized code. So instead of having the complex and the bulky code, so modular programming encourages a clean and organized code because you break you break all of the program to each pieces, and each pieces should be, I mean, should have a clear, independent, and organized code, and which simplifies debugging, which means you can go and fix to the specific program you go. For example, if the problem is happening here, so you can just go here and fix the program. And also it makes a collaboration easier. Also, it supports long-term software growth because you can, when you have a modular program, you can add a new module, any module or any function you want to add, or anything you want to add, you can add. So you can expand your software as you want. And it also helps us for better testing. So you can test your program, a specific program, a specific program step by step. So it's easier to test this piece of program instead of testing the whole bulky program here. So these are some benefits of uh, modular programming. So how do you create a Python module? So a module is like simply a .py file containing a Python code. So a module, it has elements, we call them functions, classes, and variables. So functions are, as you know, that they are the building blocks in Python programming, which helps us to perform a specific task and reuse them throughout the whole entire code. And the classes, so we have classes. So they are blueprints for creating objects, or you can define as, so they are the blueprint for creating objects, which are instances of the class. So they contain attributes or variables there. And using classes allow us to define objects and their behavior. And when you use classes, so they are ideal for organizing and encapsulating related data and function into single and reusable entity. So which means that instead of having like many functions, you can define many functions. So you can you can have one class that collects all of the function we have here. So to create a module, so which is I said that it's a .py file which contains uh, uh, many functions or different classes inside. So this is a bunch of code with a .py file or .py extension. So we have a module here. So you may have the many classes here, or you may have different functions here. But when you put them in a .py file, then you will have a module. That's what I want to say. So once you have a module, you can create packages, and you can also import uh, function, I mean, modules from the package. So a package is like a directory or a folder within this, the init.py file. This is a constructor file, and when a folder contains this file here, so which tells you that you have a package. And inside that package folder, you will have modules, different modules. You have one or many. And for example, you have this module here. So this is just a simple uh, function here, which uh, give you hello somebody. So you put inside a string, then it gives you hello someone or hello someone. So I save this one as module1.py file. Then I have a folder named project. Then inside the project, I have my package. This my package is the other folder. And inside this one, there is this function here, I mean this module here, the init.py file, the constructor, and we have as many as possible modules as you like. So you have this one. So we can import these modules using the from, and always when you import, so this is the direct way of importing package from your package. So we have from, and this my package is the name of the folder that contains the init.py file. Then you can import module1. Then using module1, you can do whatever you want. Module1.greet. So greet is the name of the function here. Then so I write the string. So this is the input. So you get the result, what you have. So this is how you create packets and importing the package. So we'll see them in the different example in the demonstration part. So these are some tips when you write a modular code. So you need to keep the module focused on one purpose. So this will help us to avoid confusion. So for example, if your module is a calculator, for example, so you may write a function that did addition, subtraction, multiplication, and other mathematical operations. So, but like if you add something that do plotting also, so that will make some confusion. So instead of so in order to avoid that confusion, you just need your modules should focus on one purpose. If it's do some EDA, you should write some plotting. If it's do the pre-processing, you have to put it in the other module. Pre-processing is done with a certain module there. And yeah, so and the second is avoid circular imports. So you should avoid circular imports. So when you import a module or from the package you have, so you do not need to uh, import like circular. By mean that, like for example in the class here, so you have some definitions inside here. So you should write class something that function. So if you write functions of function, so it like it's good to avoid circular thing, because yeah, it's helps you to it will not be confused. I mean, confusion. I mean, it will not cause a confusion when you have is when you import, like if you use the direct import instead of a circular import. And the third is uh, it is better to use a clear naming conventions. So, for example, if your functions are doing addition of two numbers, for example, so you can use add so as a name instead of or using something like combination or something. So it would be good to have a clear naming convention so that you can see the name that is related. And the other is document each module. So you need to document each module means you have to save each module with the specific and clear name and include a simple test. So which also helps us. So like for example, if you have a function that did again, so I said additions. So you can have some simple test for your function that did addition. Also, you can have some test function for your multiplication or for your division of two numbers or something. So each simple tests will help you to identify if there is an error or not in your code instead of having uh, the general test. So when you run the general test, it may cause you a trouble because sometimes if the code is bulky, so it is not easy to to see where the real problem is. But if you have a simple test for each module, but it will be easier to identify early the problems. So the next is we have Jupyter Notebook. So I think you may use Jupyter Notebook in VS Code or in Jupyter. So I will show you both of them. So you can have a Jupyter Notebook in VS Code. So when you see a Jupyter Notebook, so which is the ipynb.ipynb file, so which tells you there is a Jupyter Notebook. So which is a browser-based environment for writing and running Python code. So you can write and run Python code, which you can write your code, you can get your code, your output, your text, or your visuals in one in specific document as you like. So Jupyter Notebook is great for data analysis, machine learning, and any other experimentations also. And as I said, you can save the Jupyter Notebook using this extension. Yeah. But this Jupyter Notebook has a limitation because it's not ideal for larger software projects. Because if you write, for example, if you are doing a data analysis or a machine learning project, so it's hard to finish all of the machine learning projects that you have in one Jupyter Notebook. It will be hard. But if you combine the modular programming with the Jupyter Notebook, that makes your tasks easier. And it is performance limited because when you run a lot of codes in one Jupyter Notebook, so sometimes you get stuck, especially when the data is very large. because it runs all the codes you have, all the it should train or everything. If you do everything, then the performance is limited. So it's better to use the modularized programming instead of having everything in one Jupyter notebook. And it's not suited for secure production environments because Jupyter Notebook is mainly uh, developed for development and exploration tools. So you can write your code, you can do the EDS or something, you can run some tests, but it's not for deployment purpose. So for deployment purpose, you are not going to use Jupyter Notebook. But combining these two will make combining Jupyter Notebook with the modular programming, which I mean that you have a modular program, then you can import that modules from your scripts. Then you can uh, do whatever you like in the Jupyter Notebook to show or to see what's happening there. So these are uh, the things that I prepared. So you can ask any question before we go to the demonstration. Any question? ጥያቄ የለም?
I think there are questions on the message, and a couple of them are actually raising their hands. Samay.
Okay.
So Henok said, can you clarify on circular concept? And yeah, Mehret, we're going to be sharing it.
Okay. So can you clarify on circular concepts? Okay. So I mean that the circular imports mean that in Python, so it can occur when you have two or more modules that are mutually dependent on each other. So yeah, so let me give you one example. So for example, you have a module, one module that did some pre-processing, let's say, or let's the easier one, I think it's mathematics calculation. So you can have a module that did some mathematics, one module, and the other will have the other module should be dependent on the result of the first module. So in that case, you'll have a loop. So in the process of importing this kind of module, you will get an import error or a variable error, which is attribute error. So when I say that avoid the circular imports, which means you need to write each modules independently instead of one is dependent to the other. Do you get something difficult in the second? So where can I find this PPT? I think I will share to Carrot and he will share.
We'll share it on the Slack and on the drive. So also, like as soon as the session is over, we'll find it in the Week One drive.
Okay, so do I need to learn Python object-oriented programming to write my code in modular programming? Well, like, I don't think you need to learn Python or PP because I think you have some background and you have some background on Python, so you can use. I mean, you can follow what I'm saying and you can write your modular programming, but it's also possible to read. And can you recap? I'm late. It's my fault actually. Okay. So what was uh, we were talking was about modular programming. So we start by defining a modular programming, which is, I think you can read this PPT also. So which is a software design technique which that emphasizes on breaking programs into independent reusable components. So, or in general, so modular programming, which means that you will have an independent, reusable, readable, maintainable, and scalable program. So it's a way of writing this kind of programs, what modular programming means. And why it matters, because it has a lot of benefits. You can see from the slides. So it will give you a clean and organized code. It simplifies error fixing. It will also helps you to extend your software. And we also see some how to uh, create say Python modules. So you just write your code and put it in the .py file. Then you can also create using modules and the init.py file. You can also create your package. Then from your package, you can import the package and you can use it for the purpose that you want to use. This one, and these are the tips. Yeah, and this is the notebook. So we are going to import our packages or modules and do some tasks. So this is the Jupyter notebook. How do we differentiate the modules and how do we find the relationship between the modules if we use different modules? So you will have different names for different modules. So for example, if one module is like have a task to load your data, you can call them load data or something else. And if the other module is doing some pre-processing, you can write the pre-process. So how do you relate them? You can first you can first import the load module, load data module. Then once you have the data, you can pre-process it using the other module. Is there a demo? If there is, let's go to see. Yeah, we'll see. Yeah. Okay.
I think we can move on to the demonstration.
Okay. Let me share my. So can you see the my screen? Okay. So I have this modular OPP tutorial. Then inside this one, so these are my folders. I have a data folder that contains data, and so I have the loan data. Then I have also, so I mean, this is basically the Jupyter, the web-based Jupyter notebook. So when you, if you install an Aconda, then you can easily get a Jupyter notebook. So you can write Jupyter, then you'll get the Jupyter after installing it. Or you can use the VS Code. I think that's what you're using, I think. So in the VS Code also you can have, this is my project, so the modular OPP tutorial. Then inside this I have this data folder which has the data. I save the data only. And I have the notebooks. So you can have, for example, I have this modular programming, this one. But for you, you can have maybe, you can have the pre-processing, the model, something. So when you do the data analysis, so you may have different uh, Jupyter notebooks. So, but for me, I have this one. And I have the scripts. So this is the package that I was talking. So I have the init.py file, so which is the constructor. And this one, when the folder contains this one, it tells me that this is a package. And I have a module which is called data loader. And there is a model.py, which I want to have the different models I want to test. Then I have the plots, this one .py. I wrote on this one just to use some plotting functions. And there is also a predict. So once you have a model using these models, you can predict. Then you have also a preprocess.py just to pre-process your data. So you can add as many as modules as you like, depending on the task you have. So this is the scripts, this is the package. And I have also some tests folder, so you can add, but it's empty, but you can have any functions here or any modules here, just to have a test function, just to test every of the modules here written. So for example, if you see the data loader, so it just, this is the function I have. So it can take the CSV.csv file, this XLS file, JSON file, or any other files you can add as you want. So these are the just sample codes. These are the sample codes. So you can write your own code. So I have this function here, so which gives me, when I use this load data, when I call this one after importing the module, I will show you, it will load the data from this folder, the data folder. Then I can pre-process. So we may have some intuition on the pre-processing of the data. So you can fill the missing file, you can drop, or you can encode, if you have, for example, categorical variables, you can encode them through one int. For example, if you have in the data yes or no, if there is a column, that is filled with yes or no, you can encode them as 1 and 0 or anything. So you can encode, you can fill, you can drop, and every other relevant things in the process of pre-processing data. But for me, I just use the filling missing data using different methods here. So after pre-processing, uh, you can plot or you can plot using this one. So if you look at that, we in the data loader and in the pre-process, I just use the definitions only. So it doesn't mean that I have to always use definitions. So you can write classes. I just want to show you the variety, but you can define your classes in the data loader or in the preprocessor or any other things. But here also I just have a class which is called plot utils. Then inside I have a lot of uh, functions. One is it gives me a histogram. The other it gives you scatter plot and the line plot or any other plots like you can add. So but like if you are just using a Jupyter notebook, you need to write these codes everywhere. But from now on, for me, just I have these modules here. Just I only need to import with appropriate. Uh, I mean, just following the paths, following the appropriate paths. I just import these things and reuse them. So let me show you. So these are just the functions. If you have, so you if you want to define a function, you just use a def keyword. Then you can have the name, this add, but so you do not like instead of add, you do not need to use sum. So I can use sum also, but sum is like it's a keyword in the Python, in the original Python. So instead of using that one, I just use add. So it gives me this one, and you have this function. So which means you have this keyword, and the result is so instead of like in the I mean in the beginning of learning Python, we use a print. So when you use functions, you just use return, which returns the result. So we have using these definitions, I can form also a class. I can call them its calculator. So this is how you define a function and class. Then I think one of the things I want to show you is this one. How can I use these packages in my Jupyter notebook here? So I first get the absolute path to the project root. So which is I use this import ss and import osr. These are import the system and the os, which is they are the Python modules. I mean the standard Python modules. These are not my modules. So these are the standard Python modules which comes from the Python programming. So I have this one, then I write this code just to get my it says Python environment, but because I need to put it in the Python. Yeah, sorry, I think let me show you in the browser. Yeah. Yeah, sorry because I did something wrong. Yeah, I have this one. So my directory is the project root is this one. So this is the project root, or you can use this one to get so where we are. So I have this one. This one helps me when I want to load the data. So I will import the modules. So I have the script folder. If you remember, I have the script folder, which is this one. This is the script folder. It contains all the modules I want. Then I should put scripts.data loader. So data loader is the name of the first module. Then I import load data. So load data is this. Yeah, this is the, it contains just one function. So I have load data function. Then the same is true for preprocess. So I have the preprocess data, which is the name of the function. I have this one. And from this one, from script model, you can import train model and same model. So in the model part, I have this function here, train model and same model. So, but like when you have a lot of functions, for example, you may write 15 functions. So you do not need to you do not need to state every function names here. So instead, you can put just the asterisks here. So if you just to import everything, so you can use the asterisk just to import everything that you want. So if it contains 15 classes, for example, you do not need to write every classes. So you just use asterisk to uh, import all of the things that you want. So I will run this one. So it's working because it's importing everything here. Then, so this is just a Python, standard Python module, pandas PD. Just it helps you to read, um, to load the data. So this, then I will use the load data. This is the load data function from the data loader. From this module, I have the load data, so which will load my data. So it's loading. Then you can do whatever you want. You can see the the size of the. Okay, Henok, you can ask.
Yeah, thank you, Sumay. Maybe a quick question here is uh, on your load data function, you already imported pandas, and soon after, you are explicitly importing pandas as on a separate line. Why is it required, or is it
No,
something
it's
redundant?
yeah, it's not required here. I just right. I just want to. I put it this one just to show you this. These are my modules, and these are the standard module.
Thanks.
Then you can do the shape. You can do some statistics. So you can have. From before pre-processing, you can see the statistics also. You can do whatever you want after loading the data. Then using the pre-process. So the pre-process, it will give you the X, Y, and encoders. So this one, so you can run this one and you may have different, you can get X's or Y's or something. So this is So this is the code that, after pre-processing, it gives me X is going to be this one, and Y is going to be given by this one, and the encoders is going to be this. So this is the result from the pre-processing. But the thing I want to show is process data is the function from the pre-process .py file or the module. So I import it and I use it here. Then you can plot also. So in the plot utils.py file, this one here. So I have a class. So I have a class plot utils. So I just call this one plotter. You can write plotter just df. So this is initializing the plot utils class. I'm initializing the class. Then after initializing the class, you can do again. You can play around. So this is not related to the module, but just I want to see what the columns of the my that's my data. So I run this one, and the first one inside the function. So there is a function which is called histogram. So it will give me a histogram. So plotter, I have this plotter, which is coming from the plot utils class. This is naming. So I name this one by plotter. Then I use plotter with histogram. Then again, do whatever you want and get the result. So for me, I just want to see that the loan amount distribution. So I get this result here. And this is the histogram I have according to the data and the function I defined. So I got this histogram. Then you can also see the scatter plots. So you can see the applicant's income and the loan amount. So this is how the graph look like. But again, this dot scatter. So this scatter is the name of the function. This is the name of the function inside the class plot utils. And I have also another one, dot line. So this is the search, the line graph. And this is the name, this line is the name of the function again inside the plot utils classes and in the plotter utils .py file or in the module. So again, you can run and get this here. So these are some sample plottings, but you can add, you can write whatever you want to see whatever you like. So once now we have a data, we process, we see some plottings. Then the next is I have a model. So there is a model.py file, which is a module. Then I import that module. Inside that module, I have this function train model. So this is the train model. Then and again I have the save model. So I should train. Then I will save that model. Then I will use that model to and do some testings. So I will train the model here. Then the model is saved. So inside my thing, I just write it that the model should be saved inside the notebook, inside the notebook folder. So which is here inside the notebook here. So this is the saved model I have. But for you, like you can save it in another folder called, you can have a new folder which is model. You can call it model folder, then you can save it there. It's okay. Then I have to test. So I train the model, then I have to test. So I test this model and I get this accuracy. This one, so this is not the good uh, the good thing. So I so the aim of this today's tutorial is how to use modular programming. It's not about these modeling things, but so this is not, anyways, this is not a good model I have. So I need to look at different one. But after, using some accurate models, you may get different results accuracy, but the result is something like this. So I trained, I test, and I get these results. Then I should predict a new data. So I have the predicts.py module. So I already import that one. So this is the predict function. So I have this one. And then I will predict with xtest or any other data. Just I get this one. So this is, it seems like overfitting. So, but this is how you import and use that module to do some related tasks. And the other things are not uh, related, but you can also, yeah, these are the things that I want to show. So again, you can also predict. I use the same thing here. For me, I use the random forest classifier. So this is not a good model for the data I have. But just, this is an example. So I have this one. Then you can also have plot predictions. So this is also inside the plot utils class. So there is a function called this one. So I want to see that how the loan approval is, how the loan approval is going to, is look like uh, between the actual and the predicted value, and you can plot this one. So these are some demonstration that you have to, I want to show you, but for you, you can add whatever the definition of classes or whatever you want. And just the only thing you need to do is just write it in a .py file, .py file, just to get, to have a module. Then if we have, these are, all of them are the .py files, then adding this init.py, it tells you that this folder script is just a package, and from this one you can import any modules that you, any function or any modules that you want to use. So this is what I have. Any question? If you have any question, you are welcome. And thank you.
Okay. Thanks for everyone for the session. If you have questions, please ask. If not, I think can wrap up the session here. So, any questions for me, guys? You're welcome. Okay. It's in hands. So I'm gonna assume that there are no questions. So we'll be sharing the code and the slides on Drive and on Slack as well. So yeah, thank you guys for joining and have a great day.
Okay, thank you.